Hey, what's up? This is Doug with Design 8 Studio, and this is a VEVOR name brand 10-inch bandsaw, and it is only 1/2 horsepower. I replaced the stock blade with one that is made for resawing, and what I found is that it does make it resaw better, but with this 1/2 horsepower motor, it's simply not strong enough for resawing hardwood like oak. So on the VEVOR website, there is a 1.5 horsepower motor that I have ordered. And I'm now embarking on the project of trying to see if I can replace that 1/2 horsepower motor with this 1.5 horsepower motor. And one of the things that I may run into is that the shaft size is, I think, perhaps a little bit larger. I'll be able to verify that for sure once I take the other one off and actually measure. But I wanted to mention that if I'm able to succeed with this, I will have made a stronger 10-inch bandsaw that is far, far cheaper than the 14-inch bandsaws that typically come with a 1.5 horsepower motor. So at that point, I would have the 1.5 horsepower, but I would not have the 14-inch capacity of those larger ones. However, at this point, I would be in for only a fraction of the price tag of those 14-inch models. So I'll put some links in the description and we'll keep you updated as we move forward. Okay, so I've taken out 2 bolts with 1/2-inch heads. One here, which mounted here, and another one through this, which mounted right there. And you can see by this slot that allowed the position of the motor to be shifted for purposes of tensioning this pulley against the belt. I'll get some shots of the pulley. It has grooves in it that match grooves in the belt, and you can see there appears to be a set screw, grub screw on it in just one place as far as I can tell. This motor is smaller, but it does sit up a little bit off of this platform down here, and I am in hopes. I believe that this mount is too small, but the flange may be large enough that I can drill new holes larger out and mount it. But even then, this slot would become inaccessible by virtue of not being able to reach in here. The new motor would preclude being able to access this. So I'm not sure what all I'm going to get into. Another possibility is whether or not this hole will still be right, or whether I'll have to take out some material, and whether or not the position of the spindle will be usable. So still analyzing it more soon. Okay, these are 10mm. Okay, so this is the tensioning system on the smaller motor. The entire motor is mounted to this, and this thing pivots around this point here, with this track being for tensioning. This bigger motor, I think, would only work if I'm using this base at the bottom to have it rest on the stand. And you can see it's got slots here. And I think those slots would be how I would tension this one. This entire motor could be shifted along this axis, along the top of the stand. So I think that has good potential to work. I wouldn't even be bothered with mounting in these holes here, I would only be drilling into the top of the stand for mounting with this plate that's on the bottom, and it has four slots where tensioning can take place. So I'm hopeful there, and that would only involve just drilling 4 holes in the top of the stand, and I'll keep you updated on my progress. There's a white wire coming to it and leaving from it, and a red wire coming to it. Got a ground wire that's grounded to the motor frame cooling fins. Okay, so we've got 2 screws holding this on. Plug for the unit enters here, goes to the switch, and the wiring goes from the switch down and out here. So that's what we're dealing with. The decision I've got to make is, do I want to use this wire for the new motor and basically disconnect from here on the old motor, or do I want to keep this wiring with the old motor and put some new wiring on for the new motor? So I've got to ponder on that and make a decision on that. Okay, I think this black and white are coming from above where the main power supply. No, can't really tell just yet. Still trying to sort out what is what. Coming from where and going to where. Now we're getting somewhere. Okay, so this one is the one that's headed down. This one is the one that's headed down. So I've got my 2 legs, the AC power, and a ground. Okay, I should be able to feed this down through and out the lower end headed toward the motor, and leave this wire connected to the old motor for use somewhere else. And I'll need to try to find a matching 3-wire set that is heavy duty enough for the amount of amps that this thing draws. I think it's like 15 or 16 amps on 115 and half that on 220. All right, just like that, the wiring is freed from the old motor. I'll simply take off these little niceties here for whatever new wire I come up with, and I'm now on the hunt for some new wire for the new motor. As you might have guessed, I'm going to leave this little shoulder system with this old wire with the old motor because it's well suited to this this plastic box that's attached to the smaller motor, and there's no sense in bothering with it on the new one. Show you the specs here for this motor. Okay, so regarding the wiring, there's 2 screws that hold on this cover that has rubber gasket inside of it, kind of a thing, and this warning label on the outside. Inside, the wires are all wonderfully labeled and numbered, and as you probably noticed in the earlier portions of the video, there is this nice wiring diagram on the label on the motor, and it has 2 columns. One is how to set up for 115 volt, which in America is often called 110, 115, or 120, and then another for how to set up 230 volts, which in America is often called 220, 230, or 240. As you may know, the electrical grid has been slowly running hotter and hotter. So what years ago was called 110 is now called 115 or 120. So you may be wondering when you see INS on a diagram like this, it means that the wires numbered 2, 4, 6, 7, and 9 need to be gathered together and then carefully insulated. INS stands for insulation. And so I'm still trying to decide. I have the capacity to run this at the higher voltage. If I plug it in out of my shop, I have a step-up transformer, but I'm seriously considering setting it at the lower voltage, because if the motor is powerful enough to do resawing an oak at the lower voltage, it makes it much easier to position this saw at different places in my shop without having to be bound to that one location. So I'm probably going to wire this lower voltage first and try that, and then I can always come back and rewire it if I need to go with the higher voltage. Another possible reason for switching it from the lower voltage to the higher voltage is if I find myself throwing breakers because I'm drawing too many amps, because I think it uses half the amps when it's running on the higher voltage. Meanwhile, I'm going to use a tool to take off this pulley and see how we're doing regarding the shaft size. So speaking of shaft size, there is this plastic sheath that came on this, and I have removed that, and so now I can go ahead and measure with my calipers 16.2, 16.15. All right, that's millimeters. So the shaft on the smaller motor is 14, and the shaft on this larger motor is 16.15, 16.2. So this one is a larger shaft. So that means I'm going to have to figure out what to do about the pulley because it's made for a slightly smaller shaft. I'll have to check into that and see what my options are. This is a 3 millimeter, and it's the right size to take this. Okay, that was on good. I'm sure you heard that pop. Okay, set screws loosened now. Okay, so this is the particular type of pulley that I'm looking for a way to get it to fit onto that larger shaft on that more powerful motor.
Hey, future me again. Some of you that are astute have probably noticed by now that the smaller shaft has a flat, while the larger shaft has a keyway and a key. I did eventually notice that and considered it as I worked to get the new pulley that eventually was used. Here's some footage regarding the gland, which I started off calling a grommet, and here's a shot of the hole on the new motor where a new gland was needed. This is the result of 3D printing, a file I found online, and I was eventually able to make it work. Regarding the needed power transmission wires that you see me getting ready to install here, I was able to find a nice thick power cord that was rated for lots of amps, and when I checked the lettering and the identification on it, it matched exactly that which was called for, and so I was able to cut off the ends of that power cord, and I used a crimping tool to install the proper terminals on each end, and that power cord has been working great. Here you'll notice that part of the 3D printed gland was too small to fit, and I had to enlarge it in the slicer, in fact, twice, and reprint a couple of the parts in order to get it to fit.
Okay, so I reprinted both this nut and this threaded cap bigger again, this time a full more than 10% bigger. And I should mention that I'm using a thicker wall, perimeter wall, and a thicker layer height than what most people would consider normal. And if there is any over extrusion, then the effect of it gets doubled whenever you're dealing with threads, male and female threads. And plastic is particularly grippy. And so I've finally been able to get this to where I can get it on there, but I need a way to hold it. And this is round on the back. If I had a suggestion for a remix of it, I would suggest that this back part be octagonal instead of round. Nevertheless, I'm going to try to reach in and hold it with some type of pliers. Going to pose a bit of a challenge because there's not much to get a hold to.
Hey, future me again. If you ever find yourself in the same situation, have to enlarge in the slicer something that has threads, such as in this case 2 parts that have female threads, be very careful to make sure you enlarge it only in the X and Y axes. If you enlarge it in the Z axis, you will throw off the spacing of your threads.
Okay, so that took longer than I thought it was going to take and was a little harder to do than I thought it was going to be. And it was still faster than trying to order something and waiting for it to arrive. That back half really needs to have more to grip and hold on to. All right, so we're now ready to get all of the wires tucked down in here and power this up for a test to make sure we've got it spinning the right direction, which for us is going to be clockwise. Oh, I've still got to do the grounding screw. Okay, I've got the grounding wire attached to the ground screw. Okay, so we've got this all ready to ground it to the frame, plug this into the switch. So let's head over and try a test to see if we've got it going the right way. Okay, so we've run our wire from the new motor in through the chassis and up here, and now all we have to do is attach the grounding wire plug it in. All right, so we're going to do a test to see which way that the spindle is spinning, and based on if it's spinning the right way or the wrong way, I may be done with the wiring, or I may have to open this back up and change which wires are connected which way. Because we need the spindle to be spinning clockwise. When it spins clockwise, then spin this the right way and have the blade turning the right way. So just a quick test here. And the motor is not mounted yet. It's just sitting on the stand with some cardboard to keep it from scratching the paint on the stand. And so the motor may jerk just a bit, but we'll be able to turn it on, then turn it off, and just watch as it spins down, and it will get slow enough that we'll be able to tell which way it's turning. Okay, so the motor is spinning counterclockwise, which is opposite of how I need it to spin. So I need to take the motor back apart, take the cover back off, and change the wiring in here to get it to spin the other way.
Hey, future me again. I could have avoided the whole issue of wiring it wrong if only I had paid attention to a little note on the bottom of the label saying that if you want it to run clockwise instead of counterclockwise, you switch these two wires. There it is. Kudos and thanks to my friend Randy, who is an electrical engineer, who pointed out to me that this type of motor doesn't switch direction by changing the two lead wires, but rather you look for that note and find that note and do what it says. Thanks, Randy.
So I've now rewired it to have that accomplished.
I did a lot of shopping, a lot of researching, and a lot of trying to find a pulley that was the same poly V groove pulley, but large enough to fit on the larger shaft and to accommodate the keyway instead of the flat. As you can see here, the old motor with the old pulley is a shaft with a flat, whereas the larger shaft on the new motor has a 3/8 inch keyway with a key in it. And so I eventually kind of gave up on finding something that would fit that new shaft and match that poly V groove. And kind of in desperation, I even toyed with the idea of using a 3D printed plastic pulley. but realizing that with 3 times the amount of power and increased torque, that would probably kind of be unwise. Even though the driven pulley on this thing from the factory is an injection molded plastic pulley, the drive pulley from the factory is metal, and I eventually realized that I needed to go with a metal pulley. And even more than that, I decided to switch from those lateral grooves in the Pulley V setup to teethed cogs approach with ribs on the belt and teeth on the pulley, and that gave me a greater torque, gave me greater grip, so that I could really do a better job of transmitting the additional power to the blade. Here's a quick shot of me testing with that printed pulley in place, just to make sure the motor is spinning in the right direction, and just kind of standing in awe of watching that thing turn. Off camera, I took measurements and made a diagram of the slots and holes on the bottom of the motor mount, and then measured carefully where to drill. Here I've already drilled most all of the holes, 3 of the 4, and I'm down to drilling the last one. And then next up will be checking whether or not the shaft can fit into the opening in the side there headed toward the wheel without making contact, and realizing that I did need to use a Dremel tool to remove some material from that hole in the side panel so that the shaft would not grind and make contact against that side panel. As is typical when drilling in metal, I started off with a smaller bit and then switched up to a larger bit to finish off the size of the hole. My trusty drill bits are well worn and could probably do with the sharpening, and so I had to do a little bit of side-to-side motion in order to get the holes drilled. The test run you see me doing here was done with a 3D printed plastic drive pulley and a stock injection molded V-groove driven pulley. And as it seemed okay here, but as soon as I tried to cut some wood, I realized that the lateral grooves of the Pulley V structure was not a strong enough transmission system. I did not have enough power of torque from the motor being transferred successfully to the blade. So I gave up on the plastic drive pulley, and that's when I switched to a teethed pulley system and ribs on a belt for the teeth. And it meant that I needed to design and 3D print a plastic driven pulley. I was okay with it being plastic, even though I wanted metal on the drive pulley. The toothed belt bought on eBay is made for a Harbor Freight belt sander, model 38123. And you can see here it says 160XL09-2020. I'll put a link in the description for the belt. As careful as I could measure the distance between the center of the axle over to the shaft for the motor was a 100 millimeter distance. When I took the wheel off, of course I had to pop a little circlip off to get this off the axle. When I took this off, I found that this stock factory pulley on the other side of this lower wheel was an injection molded plastic pulley. That, combined with the fact that I was moving from a Pulley V belt to a toothed belt, gave me the confidence to try designing my own pulleys in Fusion 360 and then printing them with PLA+. I started off with some real fast mock-ups that were printed with no top and no bottom, just to get to a point where that I knew I had the design correct as far as being able to mesh with the teeth. And then I went to one thin wall prototype that had very low infill and not very many perimeter walls, just to make sure that everything was fitting good. And then finally to a thick wall part intended to be functional that has a high infill rating. Once it slips on, it's held in place by 3 screws. I'm just letting these M5 by 30
millimeter screws cut their own threads into the plastic. I should mention that I had put Loctite 243 onto both of the grub screws. So here we have the 3D printed pulley that I designed using Fusion 360. And as you can see, I'm going to have to loosen the motor off of its motor mount and get this nudged over some in order to get the belt in place, I think. I've loosened the motor and the motor mount to be able to move this shaft over. I'm thinking it might be easier to put it in place and then get this positioned onto the shaft up top. All right, I wasn't getting it seated all the way down. Now I am, but I've clearly got too much angle on the belt. So having that seated all the way down in is a problem with the motor mount's current location. Okay, so this is the motor mount side of the VEVOR 10-inch bandsaw, and these motor mount holes are new. I started off with 4 holes that were on the lower side of these slots, and then I actually found that I needed the motor to be in a little bit more because of its shaft length, and so I had to lengthen these slots out just a little bit. So I'll try to take measurements of this in case anyone else is wanting to do the same thing. Okay, so I've got this ruler lined up with the edge of the fold, not the edge of the flange down at the bottom, but the edge of the fold up at the top. And this first hole is from about 168 millimeters over to 178 millimeters. And this next hole is at about 292 millimeters to 302 millimeters. And then measuring from the riser, we're at about 84 millimeters on the first hole and about 152 millimeters on the second hole. Okay, so here you can see I've got the first 2 mounted, and you'll notice that I'm in those slots, not the holes, but the slots. And one other thing to notice is that in order to raise the motor up slightly, I've got some washers underneath the motor mount. These are just barely snug down enough that I can still move the motor a little bit so that I can get some tension onto the belt when I get the belt installed. So now I've got to go around and do the other side. Okay, so we finally have both sides of the motor mount loosely attached. It can still be moved a little bit, but we're ready to come to the point of attaching the key is slipping out of the keyway as I'm trying to install this. key is still slipping out of the keyway. So it seems the key is a very tight fit in this pulley that's causing it to want to slide in the keyway. So I'm going to tap it down into the pulley first. See if we can get this seated this way. Okay, I feel pretty good about that. Okay. We've got the motor tightened up in the motor mount, and the belt is nice and tight. We've got free range of motion here. I still need to put this circlip back on, and I don't have the right tool for putting that on. So I'm going to have to kind of improvise on getting that clip put in place. You can tell why people buy a tool made just for doing this. Okay, I was finally able to get that circlip on by grabbing the two ends of it with two pairs of needle nose pliers and pulling apart, and then sliding in place while pulling apart. Okay, so next up is trying a trial run without the blade installed. And so here we go. This is 3D printed plastic pulley for the large pulley, the driven pulley, and a custom ordered metal pulley for the drive pulley. First time trying to run it. Okay, so that seemed pretty good. So next up will be to try it with the blade installed. Okay, so we've got the new 1.5 horsepower motor in place, and we've got the blade installed, and we have a functioning bandsaw. It's a VEVOR 10-inch with an aftermarket blade that's made for resawing, and this is increased from 1/2 horsepower to 1.5 horsepower, and I'm thrilled. And so next up is to see how well I can resaw with this increased horsepower. So there it is, folks, a VEVOR half horsepower motor replaced by a VEVOR 1.5 horsepower motor. Significantly bigger motor, hangs off the back of the stand. I think this is going to work good. I should also mention that it comes with a regular blade that has a very thin cross section that's made for cutting curves, and I paid quite a bit to get this bigger blade that has a wider cross section in order to be able to do resawing. This blade is specific for resawing. That greater distance across the width of the blade helps to keep the blade straight as it does the resawing. This was the biggest. They make bigger, nicer resawing blades, but they come in the wrong length to fit on a 10-inch saw. This was the biggest blade suitable for resawing with carbide tips that I could find for this 10-inch VEVOR bandsaw.
Speaking of costs, let's go over real quickly how much I have in this whole saw, including the original purchase and everything needed for the upgrades. First off, for comparison's sake, as you know, you can easily spend $1,000, $1,500, $2,000, $2,500, $3,500 on a bandsaw that has a 1.5 horsepower motor. On the VEVOR website, they sell 3 bandsaws to choose from, 2 with a 10-inch cut width and 1 with a 14-inch cut width. The 2 10-inch cut width machines are not the same. The cheaper one that sells for $196.99 as of the publishing of this video has only a 4-inch cut height and a weaker stand. The better 10-inch has a 6-inch cut height, which matches the cut height of the 14-inch. It has a better, stronger stand than the cheaper 10-inch, and it has some other bells and whistles on it, and it lists for $265.99. However, I was able to catch a coupon for it, a discount promo, and buy it for only $240.99. The 14-inch width bandsaw that has a 6-inch cut height and a better stand has a list price of $921.99. So again, I paid $241 for the VEVOR 10-inch bandsaw. The 1.5 horsepower VEVOR electric motor lists on their website for $185.99, but I was able to pay less than that on an eBay purchase of it, getting it for only $144.99. So I saved $25 in a coupon on the bandsaw, $41 by an eBay purchase of the 1.5 horsepower motor. I was able to buy the toothed drive belt for a Central Machinery Harbor Freight belt sander for only $9.49 on eBay, and the XL timing belt pulley from Masumi USA for $38.04 plus $14.59 for shipping, making it a total of $52.63 delivered. And finally, although this shouldn't count against me on the purchase price, because this amount would have to be paid if I was upgrading to a resaw blade, no matter which bandsaw I bought, I purchased from HighlandWoodworking.com a carbide-tipped resaw blade, 72 inches long, half-inch width, for $124.99 with shipping of $12.99 for a total of $137.98. This brings a total, if no discounts are involved, of $652, including the carbide-tipped resaw blade. With my discounts and promo codes, I'm in for $586.08. Now, if we compare this to a Harbor Freight 14-inch bandsaw with a 6-inch cut height, it has only a 0.75 horsepower motor, and it is $479.99, and again, doesn't have as strong of a motor as the one that I have. If I add the carbide-tipped resaw blade, which would be needed either way, onto that Harbor Freight bandsaw, it brings its total to $617.97. And so my savings, with literally double the horsepower of the Harbor Freight bandsaw and having the same resaw cut height as it, I'm saving $31.89. Plus, I still have that half horsepower motor that I took off of the VEVOR for using it for some other project. I still haven't decided what I'm going to use it for. And saving hundreds or even thousands if I compare this to several other models that do come with a 1.5 horsepower motor. I hope this has been a help to you, and if you are heading into doing the same kind of project, please feel free to post any questions you have in the comments, and I'll do my best to help. Once again, this is Doug with Design 8 Studio. If you found the video helpful, please click like and consider subscribing. And until the next video, I wish you happy making.